Good morning, everyone. Today, finally, we're gonna start our first session of internship, which is aimed to learn to teach you how to use artificial intelligence and bioinformatics techniques to unravel the diseases mechanism behind it using public data. So before going into the course, I want to discuss some rules. If you want a certificate from our company, so you have to follow these rules, and in the end you will receive certificate successfully. Otherwise, if you don't want certificate, you are not obliged to follow these rules, but still you can watch our videos and do the examination for your own learning purposes. So what I want to discuss is in the rules is that first is that when we upload our video, so you have to watch the video and see. I want to tell you one thing is that first part is of like we are doing divided this course into like this. So first part will be theory, which I gonna teach, and then on the next day my colleague gonna make the video of the art for the practical session, so you will have hands-on practice for that. So next day you're gonna get the video of the practical. So in this way you will have both videos, and this will go for a week. For a week means that, for example, if we start now, it could be start any day, but for a week means that you will have 6 classes at least before the examination. So that examination contains the quizzes from the whole week what you have learned. So you have to watch both theory and also you have to watch the practical session. And of course you need, because there was some users was asking if we can use laptop or mobile. Of course you have to use laptop, because how you can do in mobile. So for practical part, of course you need a laptop. So you will install the program and you will run code by yourself, and that's how you get the confidence in running the code. So in the second part you finish this, and when these are finished on the completion of first week, we're gonna take a test which is on Kahoot. Why we choose Kahoot? Because in that way we can put the timer for the question. For example, if we are putting the quizzes, we will give you 20 seconds to answer or respond to a question. Otherwise, that means that you failed to answer the question, so it will go to 0 marks. So we put that to evaluate the candidates that who is learning. Otherwise, like there are many candidates which can use the ChatGPT or any kind of generative models to answer the question, so they learn nothing. So we are just praising you to learn from us and be able to apply these techniques what you're gonna learn in this course. So we are just helping you, not to make difficulties for you. So after the Kahoot test, if the candidate passed all 4-week tests, they have to do the mini project, which will be like, first we have to teach everything to you, then we ask you to generate a mini project using public dataset, and in the end you're gonna present your data to us in the presentation, and you're gonna tell us how you obtain the data, how you design the study, how you obtain the biomarkers, and what these biomarkers are. But first we're gonna teach you, and then in the end, if you are successful in all these 4 steps, then fifth step is that if your project is successful, we're gonna feature it in our website, also in our GitHub page, and you can also show to some company or wherever you are applying, you can show your skills to those companies. So this is necessary for to obtain the certification. So let's start from our first class today. So today, as I discussed already, that I'm gonna tell you the basics of machine learning algorithms and how they are useful for biological data. So I'm not with the introduction. So I want to tell you that why machine learnings are useful in our daily life and almost become our like daily needs. Like a mobile, you use ChatGPT and all other modules to do that. So machine learning is just a part of artificial intelligence. So biggest part is artificial intelligence. So here, for example, we have the big circle, which called artificial intelligence. Okay, this covers whole area. Then if you say that where machine learning stands, is basically stands here, machine learning. So this could be machine learning part. Machine learning can hold also, you see that now there's deep learning, so here is the deep learning. Also now is generative models. So generative models are like just this part, while this is full machine learning, and artificial intelligence hold on. Also there is one part which is called NLP, which is natural language process, which also this ChatGPT, the generative models use, but it's a bit outdated now, so it's still improving. So in this internship we're gonna use just machine learning, because we are not using generative, and we are not, maybe we used deep learning in the end, but we are not using NLP. So we are just focusing on the machine learning for now. Okay, so how machine learning is working, we're going to discuss later, but first I want to emphasize that how many types of the machine learnings are, and what you can do with the machine learning. So machine learning basically have like 4 major parts, like it's a section of machine learning which are divided. So you can say that we have 4 parts of machine learning. Okay, so in this internship what we use is that we will use frequently supervised part and unsupervised. Okay, so this is just one and this is second. Okay, why we are using this? Because these are most widely used in obtaining the biomarker, which we're gonna learn throughout these days. Third part is called semi-supervised, which is basically a combination of supervised and unsupervised. So both techniques used in semi-supervised. Fourth is reinforcement. So in the reinforcement, we don't use much in the biological applications, because this works different from these 3 classes or sections of the machine learning. So how reinforcement working is that it's based on like live interactions, or if you are building the robots or trying to do robotic things, so you need the live interaction with the robots, they have to work in the real time. So in this way you can use the reinforcement. But in the biological I didn't see many examples to obtain the biomarkers or whatsoever. So we're gonna focus mainly based on supervised and unsupervised. So here supervised, unsupervised, and semi-supervised you will automatically learn, because once you get these 2, so you cover this semi-supervised. Okay, so this is our like 4 types. Now since we are saying that we're gonna only focus on our supervised and unsupervised, so we're gonna see that what is actually supervised. Supervised machine learning algorithms are work. For example, today you are collecting the data. Okay, so data have data like the group inside the data, so you know that where you collected your data from. So for example, if I want to train a machine learning model which is supervised, that means that I have to collect the data from the known groups. So in our case, maybe I collect the data from cancer patients, or I collect in the same time I collect normal samples. Okay, so in this way I know that my data have like 2 groups. Okay, so my data has 2 groups, and I have to train the machine learning model based on these 2 groups. How it's gonna work is that we have to, like for example, you have around, let's suppose you have 10 samples of these. Okay, you have 10 samples. So how machine learning gonna learn is that you're gonna use like 7 samples for training of machine learning and 3 samples for validation of the model. So this is called you can say validation technique or holdout. Okay, so what is holdout here is that we hold out 3 samples not to show machine learning while training, otherwise it gonna learn also from these 3, and then model gonna give you the overestimated results because it already know the answer. So we always have to keep some validation sets. So this is how the supervised learning works. Okay, so I'll remove this because of the space. In unsupervised learning, unlike the supervised, you don't know the data. So you only know that where you collect the data from, but you don't know the group inside. So for example, if I want to study today how many types of breast cancer, let's say, exist in the biological system. Okay, so what I'm going to do in unsupervised is that, for example, let me write okay, so in unsupervised, what my data is that I collect data which collected from cancer. Okay, and cancer is the breast cancer. Okay, so in unsupervised learning, we know that we have data and we have the expression. For example, expression could be anything, proteomics, metabolomics, or genomics, transcriptomics, whatever you give, and this expression of breast cancer patients. But our goal is that we want to know that in our data how many groups actually exist. So for example, you collect the 10 samples, okay, you provide into unsupervised model, and what it's gonna do is that it's gonna make the groups based on the similarities of the samples. So for example, what it's gonna do is that it's gonna take the, let's say, I'm just giving example, there are sophisticated algorithm behind it, but I'm just giving you the idea. So what it's gonna do is that it's gonna cluster the samples together if they are similar to each other. What means similar is that they are similar in the expression of the breast cancer. Okay, so it's gonna make like 3 samples of first cluster, and then maybe the second cluster contain 5 samples, so we have like 8 samples now. And then what we do is that we're gonna maybe 3 are these. Okay, so in this case we have, like in our breast cancer data, we have 3 clusters. Okay, so what we're gonna do now is that we're gonna take that, okay, based on which expression, for example, which protein these clusters were made. For example, let's say that you have proteomics data for this breast cancer which contain the 10 proteins. Let's say in the real world we have 10,000, but I'm just giving you example. So we have 10 protein. Okay, so maybe this cluster made up of or is like expressed differently from this cluster by 4 proteins. Okay, so 4 proteins are actually describing over this subtype of cancer. Okay, and maybe this is from 5 proteins, and maybe this is from 1 protein which is like associated to this cluster. Okay, so expression wise we figured out that in our data breast cancer samples we have like 3 clusters, and these 3 clusters could be the subtypes of the breast cancer. However, at this stage we actually don't know, so we do further analysis, but this is how the unsupervised learning algorithm help us to find the initial results. So also unsupervised learning is doing another thing, which is that which subtypes are similar to each other. For example, you take the distance between these clusters are similar than this cluster for this. So what you gonna say purpose is that these 5 protein subtypes and this 1 protein subtypes have some kind of relation with each other. So these subtypes could be maybe targeted by one drug or two drugs. So they could maybe have the similar therapies you can use in later stages, but we will learn it later. So in this part, we have learned that how many types of the machine learnings are and how they are working. So for now we just focus on the supervised learning, because which is very important for us for the classification of the samples, or you can say the precision medicine is very important, and also to obtain the biomarkers. So what we're gonna use, what we're gonna cover now is inside the supervised learning. So let's say supervised learning, we have two more groups. Okay, so we have also subgroups within the groups. So also unsupervised have some subgroups we're gonna discuss later when we discuss the unsupervised learning. But for now we are just doing the supervised. So I'm telling you. So in the supervised learning we have we have two types further, which is called linear regression, or you can just say regression, because regression models. Okay, so this is not always the case, because sometimes we have to use non-linear as well regressions, depending on how the data are, our data, how we collected it, and there are ways to determine which model should we use for our results. So this is the first type, the linear models, and the second type is classification models. So we're gonna briefly discuss these models today. I'm gonna just discuss this regression models, and then on the next class is for classification model, because this is complicated, and this we're gonna use in throughout our all projects. So this require more time. So this will be in next class. Okay. So let us start from the linear regression model and how it works in the prediction. So for example, you are standing on the Tower of Pisa. Okay, so you are here, and you are standing here, and you throw a rock. Okay, the amount of time it takes down is 3 seconds. Okay, so this is your outcome. Okay, now we want to know that if you throw the second rock, will it gonna fall in the 3 seconds, or it gonna take time? Okay, in this case we have like the 22 meters 22 meters in the distance. The Pisa is 22 meters above the ground level. Okay, I don't know exact number, but this is just example. So how are you gonna present this data? You're gonna present like this. You make plot, and here you put your time. Time start from 0, 1, 2, 3, which actually don't exist 0, but this 0 means that when the rock was in your hand. Okay, and the meter is like maximum 22. Then maybe you have 10, 0. So how we're gonna present is that you are standing here. Okay, your data point start from here. You throw a rock and it falls down like this. Okay, so it made a sort of the linear line. Okay, so here you can see that this made a linear line. So that's why we call it a linear regression. Okay, so these data points are showing your actual data, which you actually throw the rock. Okay, and these seconds in the linear regression models called the features, which we represent our features by x. Okay, so features are what? Which can predict your outcome. Okay, so your outcome is 3 seconds here, but what it's describing is the time. So is second in time. So you have time as a predictor. Okay, so how are you gonna write this here in the regression formula, and how you make the generalized equation which will allow you to predict even after the 20 years you throw the same rock, and it will give you the prediction accurately. So you have to find out the generalized equation through using linear algebra methods and linear regression model. So how are you gonna write this is that, for example, here we say that y 1 because you throw just one stone. So this is your outcome, okay, which in our case is 3, and then this is equal to beta 0. Beta 0 is actually the time where nothing is started. It's basically initial time. So here lies our beta 0, okay, and this line is called beta 1, okay. So what you have to do is that how we make a linear model is that we start from 0, okay, and then what we do is that we have to find this is plus, so we have to find this line which can predict our outcome, okay. So what you do is that you have to find beta 1, which is called the unknown parameter, okay. So this beta 1 is unknown parameter, you have to find it, and then and how you find it? Using the seconds, okay. So our predictor here is the time, okay, and then you say that if I find the beta 1 using the feature 1, which is in our case is the time, okay, so because beta have to predict y outcome, okay. So if I take for example this x1, which is time, so to determine its beta, I can predict actually the outcome, okay, and plus the e means the error, okay. So here e is the error you make in the prediction, okay. So you're gonna sum it, okay, and then through the linear algebra and through the modeling, we're gonna determine that what beta is best for predicting the outcome of our data. So let us start with our first problem solving with for our data. So I'm gonna make my own data, for example, to teach you that how the linear models, how regression models use mathematics to find the optimum beta 1, okay. So for example, now we have we can say that let me draw. Okay, so here you have your data, and which is like this. Here you have x, here you have y, and then you put lines. So here what we say is that x is our feature or the predictors, okay. So these are our predictors, okay. It could be anything. For example, we are taking the gene expression or the gene numbers, okay. So since we are doing biotechnology, so it's better to use the biological terms. So we have okay, let's do 7 for now, and the expression of gene 1 is 1.5. Let me draw first. So for 2 is 3.8, okay. For 3 is just imaginary numbers, it's not actual data. Okay, so this is our data. So now these are our chains, which are also predictors, and this y is our outcome, okay. So here, for example, I am saying that each increment of the gene is like increasing the chance to having a cancer, okay. So for example, this is gene first, and it's increasing the chance of being cancer, okay, by 1.5, and gene 2 is 3.8, and so on, 6.7, and so on. So we have to build the model that can give us the optimal beta, okay. So remember that beta 1 is always unknown parameter, okay. It's unknown parameter which we have to search. So in our case, the beta 1 is equal to the genes, which are our predictors, and y is cancer risk. Okay, so what we do now is that I show you the trick to solve this problem. So how you find the beta 1 is that make a table which you put your x and you put the y outcome and the product of x and y here, and then you have to put x squared. Okay, so you draw a line. So here you have to put all these numbers to here. Okay, so we start from 1, 2, 3 up to 6, 7, sorry, and then we have to put our y values. So for example, this one, and 16. Okay, so what will be the product of these two here is that if you multiply this, you will get same number, and the square of this is 1. Okay, so if you multiply this, you will get, and so on, or maybe you can use your calculator to do that. Okay, so now we have to take this square of this sum product. So I'm gonna say that the square of this is 4, 9, 16, and 49. Okay, so you can take these values by yourself just to confirm. But so now our goal is to find the beta here. Okay, so in this example, we're gonna use the formula which is called the formula of the regression. Okay, so first we have to summarize our data. So what we say is that so we have the sum of x. Okay, so sum of x, how much we had is, so let's summarize our data for now. For example, by summing all, we get the sum of x, which is equal to 28, and the sum of y is equal to 60.8. Okay, and the sum of x and y, which was our product, so how much it was, 4.8, and then sum of square was 140. Okay, so now what we're gonna do is that we apply the formula, which is the linear model formula, which is, so what we have to do is that we have to find the slope, which is called slope, and using our feature, which is our gene expression, and plus beta. Okay, so this is the general equation to find the beta of any system. Okay, so in our case, how we use it is that we're gonna, so in our case we're gonna first have to determine that how we can solve this, which is slope. So slope function is, you can also can find in the Google. So in the function of the slope, we find the function, this n is the number of our samples or our genes, whatever. So we had like 7. Okay, but this is not in the formula, so I erase, otherwise you get confused. So here is our number, and sum of x and y product minus pi, sum of x and sum of y. Okay, and you divide by the number, total number of samples, and sum by the x square and minus, and you do this also a square. Okay, this is the formula that developed by mathematicians, so we don't have to go deep inside, because we are not mathematicians and we are not machine learning engineers who have to develop these models, but we have understanding how these models are working. So that's why that is a goal, to show you how is interpretation of these models and how these are being calculated, because for you as a computational biologist or bioinformatician, you have to describe each result to the clinician, to the biologist, or to the people who are stakeholders. Okay, so that's why I'm just explaining a very basic foundation of this. So let's continue this, and so using this formula, suppose, so now we put actual values of our data. Okay, so I said that n is a number of samples, then what you have is the sum of product. Okay, so sum of xy product is 3.18. okay, and then we said that it should be minus by the sum of x and sum of y. So in this case we have 28, and then the sum of outcome y is 61.8. okay, and divided by 7. Maybe I get wrong results by calculation, but this is the principle I'm defining behind it. So that's why I'm saying that maybe calculate these values by yourself from the calculator, and then you know how these are working. So here we put everything according to our formula. So what we get is that after solving this, you will get this score, which I pre-calculated. .4. Okay, so our slope is 2 point this, so this is our slope value, and from the slope value you can find the beta value by putting your value with the slope. Okay, so the beta, to determine the beta value, we also have the formula for that, and in the formula you put like sum of your outcomes minus by like slope and sum by your features, predictors or covariates, you can say, divided by total number. Okay, so let's put this, the sum of our outcome was 61, and here we have m, we have to put the m value, which is 2.414, and x. Okay, so x is 28, sorry, and total amount of number. Okay, sample numbers. So what will be the dividing of, if you solve this? So your beta will be this result, your beta will be minus 0.828. okay, here's the point. So this is your beta. So you have found the beta, okay, of this your outcomes. Now you are ready to predict your upcoming like samples, but first you have to validate that if these predictions are near to the actual values. So to do that, what you have to do is that you have to take the y value of each sample, okay, and minus by the beta. So this will be like your actual y. Here we can say is I, because you are taking one at a time, and minus by so here you have your beta, and now you have to see that how far it is from your prediction. Okay, so suppose we are taking for each sample. Okay, so to find out the prediction error, which I explained to you in the beginning, is called is error terms. So to find out, we have you have to put your outcome of the sample and the beta value. Okay, so to predict the beta, you have formula which is called y, and you put your slope features plus beta. Okay, so what you're gonna do is that for example, we were taking the sample 2, so is the sample 2 had so this comes from our slope, and then we gonna put our x, which was 2 because we took sample 2, and then we since we do like plus minus by this one, so we put just here the minus, and the result will be 3.99. Sorry, it's not the division. Let me write here 3.99. Okay, so here it's 3.99 your prediction, okay, using this beta. Okay, so you found the beta which is equal to minus 0.83, and you can predict 3.99. This is predict. Okay, and what is your actual? Is 3. How much it was? 3.8. Okay, so you see that the difference is very less, like it's just 1.8. Sorry, 1/8 after point. So you can see that this beta is predicting the values very near to our actual results. So of course you cannot predict anything in the real world, actually it is, but you can predict the similarities, the probabilities. Like you can say that okay, the rain gonna happen in like 75% tomorrow is rain, or 85% tomorrow is rain, so there is no certainty in probability. So in this way we can find our beta. So we can say that okay, we build a model where you put your you present your data. Okay, so each time you have, for example, these are cancer units from up to let's say how 7 we had, and we had value from 0 to 16. Okay, so in this case your model is predicted 3.99, which means that it should be here, around here. Your model predicted the value, and the actual value lies here. So you see that we did a beta, we started a beta which is telling us that what the outcome of this, like this is that how we validate our model, that our model based on the beta 0.83 can predict this type of data if you have units and if you have this sort of data in your hands. So that's how the linear regression model. I hope you understand the mechanism behind it and how we find to find the beta and then to predict our outcomes in terms of supervised machine learning. So in this case you would know that you have like label data, you know that you have a cancer data, and you build you determine the model that give you the beta of this one. Okay, so in the final step we just do is that what we have to do is we have to minimize the errors. Okay, so that will be our next class lecture, where we're gonna show you that how to minimize the errors if the predictions are very in with the different ranges, or if the predictions are not very close, they are very far from each other, the predicted and actual outcome, and how we can minimize it. Thank you.